Now let's discuss about the capacitance of a parallel plate capacitor with a dielectric medium. For this, we need to consider a parallel plate capacitor, which you can see here, having the two conducting plates, that is X and Y, each of area indicated as A, separated by a distance D. So here X is given a positive charge, so that the surface charge density on it will be sigma and Y is said to be earth. Let a dielectric slab of thickness is indicated as T and the relative permittivity, that is epsilon r, be introduced between the plates. Now the thickness of the dielectric slab is indicated as T, which we have seen, and the thickness of the air gap will be, that is the air gap thickness will be D minus T. Now the electric field at a point in the air between the plates will be E equal to sigma divided by epsilon naught. Here E is indicating the electric field, sigma is indicating the surface charge density, mu naught is indicating the permittivity of free space. The electric field at a point in the dielectric slab, that is E dash, will be given as sigma divided by epsilon r into epsilon naught. Now the total potential difference between the plates is the work done in crossing unit positive charge from one plate to another in the field E over a distance D minus T and in the field of E dash over a distance T. Then it will be given as V equal to E into D minus T plus E dash T. Substituting the value for E and E dash, it will be sigma divided by epsilon naught into D minus T plus sigma T divided by epsilon naught into epsilon r. Taking the common terms, that is sigma and epsilon naught, in both the cases we will be getting D minus T plus T divided by epsilon r. Now the charge on the plate X will be Q equal to sigma into A. Here sigma is the surface charge density, which is multiplied by A, that will be giving the charge on the plate X. Hence the capacitance of a capacitor is C equal to Q divided by V. Substituting the value for Q, that is charge, and V, that is sigma divided by epsilon naught into D minus T plus T divided by epsilon r, we will be getting the answer epsilon naught A divided by D minus T plus T divided by epsilon r. So this is the capacitance of a capacitor in the dielectric medium. Now let's discuss about the concept of effect of dielectric. In terms of a capacitor, the region between the two plates, you can see here the two plates are over here, which is X and Y. So it has been filled with the dielectric, that will be mica or oil. So this is the region which has been filled with mica or oil. So the capacitance of an air filled capacitor will be C equal to epsilon naught A divided by D. The capacitance of a dielectric field capacitor will be C dash, that is equal to epsilon or epsilon naught into A divided by D. Finding out the value by substituting the C dash and C value, the common terms on both the cases will be getting to be cancelled in terms of numerator and denominator, and we'll be having C dash divided by C equal to epsilon r. So finding out the value for C dash, it will be epsilon r into C. Since we knew that epsilon r is greater than 1 for any dielectric medium other than air, the capacitance increases when the dielectric is said to be placed. Now let us move on to the concept of applications of capacitor. In general, the capacitors are used in ignition system of automobile engines in order to eliminate the sparking. and they are also used to reduce the voltage fluctuations in power supplies and also to increase the efficiency of power transmission. And some other applications of a capacitor will be, these capacitors are used to generate electromagnetic oscillations and in tuning the radio circuits. So these are some of the applications of a capacitor in terms of real-time usage.